Hi, this is Jeff from the Ozark Mountains in Missouri, USA. You might think I have yet another Model 100 sitting here on the table, and nope, it's one we just had a few weeks ago. Remember, I got a 6-pack of them, and I fixed 3 and sent back to the owner. This was number 1 out of that. It's the one that had the adapter for the Chipmunk Drive in it. Well, he used it for a few days, tried to hook up the Chipmunk Drive and a multi-ROM base that was popular accessory back in the day, and it quit. So he sent it back, but as a bonus, he sent the Chipmunk Drive in the base so we can have a look at those too. Once we get the machine working again, then we'll add the accessories and see what's going on. Let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. I've got the bench power supply plugged in. This will let me see if it's drawing any current. Go ahead and turn it on. And it's dead as a doornail. It's not doing anything. The remote or the memory power switch is off here. Hopefully it's not just that. I think he said he did turn that, make sure that was on. Try it again. Yeah, black screen. That's what he said was happening. We've got about 64 milliamps being pulled. So it seems like it's powering up, but we're not getting a full boot up. That's why we have this black screen. You can see there I can change the level of blackness. So let's get this cracked open and see what's happening. Got the cover off. I noticed right away that this ROM adapter board was kind of setting uphill like this toward the back. This capacitor was bent over the other way and it didn't let this set down all the way. So that would have been my fault when I reinstalled it. The reason for this adapter is these early Model 100s that have a C in the board number right here used a non-standard pinout on the ROM. And this is a Y2K compliant ROM, so it uses the adapter so you can plug a standard EEPROM into the non-standard ROM socket. I've got this plugged back down in here right now, so we will get our power cord plugged back in, fire up the bench power supply, and cross your fingers. Oh, what a sad little problem. Gosh. All because I had the capacitor bent the wrong way. But it is working now. We do need to make sure that the multi-ROM unit and the, I forget the name of the drive. The add-on drive thing works. So, I'll go ahead and put the screws back in this case and we'll try out the other stuff. Well, here is our PSCG ROM module. This is what the fellow that owns this was trying to mount when the Model 100 quit working. The idea is you set your Model 100 on top of it like so. If I can do that, bounce on there, something like that. You plug this in where your, oh, you can't see it. Plug this in down here where your option ROM would have gone, and then you've got a rotary switch here. Can't see it there. Rotary switch right there, so you can select which ROM you want to use. And it has a jack here for charging the internal batteries that's in the bottom of this, so you got some rechargeable batteries, and then this lead goes up here so you can power your Model 100 off of this battery pack. Pretty nifty. So I took my handy dandy little voltmeter here and Measured this guy, and I have a big whopping 0 volts there. So it may be that in the number of years since he's used this, that this guy has just quit working. The batteries have died. So we need to take this board out to see. It looks like there was 4 screws and nuts here originally that come from the bottom. There's a couple screws here. So we've got 1, 2, 3, 4. This 4th one's missing. So I'll take those loose and then I'll pop this board off of here and see what we see inside. Okay, so the board just pops out like that. It's a nice looking board. Seems to be laid out quite well. As you can see, it'll hold up to 6 ROM modules. And it's got the circuitry on here to switch in between them. Nice rotary switch here. In the base, we have 5 C-sized NiCad batteries. I'm guessing they are. And our jack comes in here. The center goes through this power resistor to the negative of the battery, so it's center negative, just like the Model 100, which makes sense since we're plugging this into the Model 100. And the other lead goes over to the positive side. And also goes to outside of this guy. So since we've got 6 volts worth of NiCads here and a current limiting resistor, we're going to need about 8 volts or so, 9 volts to charge this. Let's measure this power resistor. Bands are kind of faded and I can't quite read the color code. It's saying it's about 0.6 of an ohm. I'm not sure if this is going to try to charge or not, so I'm going to plug my bench supply in here, turn it on. You can probably hear it. Set the voltage to 8 volts. Current limit's at 200 milliamps. Yeah, and it shut right off. Set the current limit at 0.5 amp. Set it to 1 amp. Yep, those batteries are acting like a dead short. So, at a minimum, we're going to need to build a new battery pack for this guy. I have to see if I have enough C cells to do that, contact the owner to see if he wants to go through that. And it just looks like they used a whole stick of hot glue to stick the batteries in. But this would have been a low volume production type of thing, so that's understandable. They got kind of like this blow molded case. The injection molding would have been too expensive. So I think if we replace the batteries in here and charge them up, then we can get this ROM module to work. I got the original battery pack pulled out of there. It was stuck in there with copious amounts of silicon RTV. So it took a while to get out of there, and I had to use the air compressor to blow all the crumbs out, but that's done. So here's our original pack, which we want to replicate. It's got 5 sub-C cells. I originally thought they were C, but they're sub-C, which is good because I have some sub-C cells. I printed a little fixture here to hold the cells for welding. I've got my spot welder out. I've got some tabs here to weld in, so let's go ahead and do that. As you can see here, I've got the new battery pack installed in the battery box. I glued that with some E6000 rather than the original RTV. It's going to take a while for this E6000 to fully set up. It holds really well, but it is a lot easier to clean up if you need to redo something than RTV is. Now, I was kind of worried about this current limiting setup for charging. It has about a 0.5 ohm resistor in here, and typically what you would see on these guys, for these old charging systems, there's no real charge controller. You'll have a reverse polarity protection diode and a current limiting resistor. So for a 6-volt pack, you would use an 8 or 9 volt DC wall wart, 50 to 100 ohm current limiting resistor, and the diode. This just has this 0.5 ohm resistor, and I talked to the owner, and he said, well, what you were supposed to do with this was use the original TRS-80 adapter for the Model 100, and you would plug it into here, and then of course this line goes up to the Model 100. So I wanted to check to make sure the charging current was okay. I've actually run this and charged it for about half an hour. But I've got my Model 100 adapter here. I've got a socket here to fit that. I'm going to plug these two together. Got some flying leads here, which is going to go through the meter here to measure the charging current. And then we'll check the voltage that's being output to the Model 100. Okay, so let's do that. So we're getting about 100 milliamps. When I first plugged it in, it was about 120 milliamps. It dropped to 100 after about 40 minutes of charging. So this is going to charge really slow. That's the way it was originally designed to do. And let me point you up here at, see if we can see this guy. Okay, now we'll measure the voltage going out to the Model 100. As you can see, that's 6.5 volts, which is okay. The adapter for the Model 100 is a 6 volt, I think 600 milliamps. Let me grab it here and we'll take a look at it together. Okay. So 6 volt, 400 milliamps. This is unregulated, so the open circuit voltage on this is about 8 volts. If you were to draw 400 milliamps out of this, it's going to be close to 6. So the battery pack is loading down our adapter, and that's slow enough where it's going to charge. This is going to trickle charge. It's going to take forever to charge, but we're not going to be in as big a danger of overcharging it, and we'll wind up with a safe voltage to output to our Model 100. So I'm going to let this set for another few hours to let that glue cure. There is about, I don't know, maybe 3 millimeters gap between the top of the battery here and where the board sets. I may put a couple pieces of foam along here. That way, even if this gets dropped from a height, the battery's not going to, be in there banging against the board. There'll be some cushioning in there. So our E6000 glow setup now. That battery pack is firmly glued in there. There was not space for any foam, so I added some Kaptan tape on the bottom of the board, although they had trimmed these leads really flush, so it probably wasn't a problem, but just like to be safe. So I'll go ahead and get the screws and nuts put back on here. I did find the missing screw and nut that was in the box, and the nut was actually down in here. So I'll get this put back together and then we'll try it out. So I got this flipped over and I was worried because I didn't see any sort of indication as to which way this was to be plugged in, even though it really only fits one way in here. And when I looked at the bottom, I saw it says pin 1 here, pin 28 here. And if we look on the silk screen here, this says pin 1 and pin 28. So with that rotated around like that, that should plug right in there. And they made some of these with, got a little notch right here so you could run the cable out with that cover on. Okay. Made myself a note here as to how to fire up those ROMs. Okay, we go into basic. Let me widify here. There we go, widify. And we go call 63012. No arguments. And yeah, that's not doing anything. Okay, let's try switch setting 2. Call 63012. Same situation. That could be we don't have a good connection here on this castellated board. These do look a little tarnished. All the fingers in here look good. I'm going to pull this guy off. I'm going to pull out an option ROM module from the here we go. All right, the type of these little circuit boards can be a little tricky. So this would get inserted this way. Okay, I'm going to get this seated down in there and we'll start again. Okay, option ROM module is plugged directly in. The ribbon cable from this guy is not plugged in. But it's getting in the way. So let's try call 63012. That did work. Okay, so we know our ROMs are good. We've got another problem. Control, break, reset, start from scratch again. All right. So now what? Well, probably unplugging and plugging these ROMs into the sockets is not a bad idea. This is just a hot air solder layer. Here on the cancellation, another thing we can do is take a fiberglass brush and very gently brush those and shine up those points, get rid of any oxidation there. Just like that, shine those up. Plug him back in there securely. And that does say ROM 1, ROM 2. So I'm going to do the same thing for this ROM, and I'm going to do the same thing on this connector. And we will try it again. Okay, all the contacts cleaned. Fire it back up. Call 63012. And nothing. Okay. More investigation is in order. I checked a few things on this board. It looked like our rotary switch here was wired to this 74HC11, which is 3 triple input AND gates. And I rotated the switch and measured the outputs, and all the outputs were toggling and the inputs were toggling. So it seemed like the switch is working okay. We had 5 volts here, which comes from the Model 100. There looked like maybe a little bit of corrosion on one of these 3 electrolytic capacitors here. And I pulled them, and sure enough, they were leaking. There was one trace eaten through right on this corner. I'm going to pop some pictures up here. So I swapped the caps, and amazingly, looking real close at these 0.1 microfarad bypass caps along this edge, the ones in the middle were corroded. That wasn't from the leaking caps. That was from the 9-CAD battery outgassing. So for the leaking trace, I'll pop a picture up here, but you can just see it there. I just used the capacitor lead bent over to jump over where that trace was missing. I sealed up this area with some acrylic sealant last evening, let it set all night. And so now we'll try this guy out. And spoiler alert, I already did that to make sure I had it working. Okay, let me go try to raise this up and get rid of the reflection. Okay, we're starting from a fresh reset here. Let me get it so you can see it. There we go. I've got this set to number 1, which is disk 4. So we go into basic and go call 63012. This is written on the ROM. And you see that started up. So disk name, stat, size, kill, save all, disk plus. So, yep. Now, in the manual for the ROM, it's going to tell you, to go into basic and type in something else or do something else to kill that so you can load the next ROM. So that's what you would want to do. I mean, kind of like the scorched earth method is to go control, break, reset, which completely resets everything. You lose all your files though, which is the bad part. And before swapping ROMs, we want to turn it off. Then I switch to ROM 2 now, which is Super ROM. Okay. Same call 63012. This is a pretty common address to start a ROM at. They're not all there. Some take arguments. So just got to look at the documentation. Now we have Super ROM running. Excellent. So just some bad electrolytic capacitors. It kind of surprised me. Anyhow, we got it fixed now. I'm going to pop it back in the case. Notice how the battery pack here and the board that does all the ROM switching goodness are completely separate things that just happen to live together in one house. And just an idea of how things have changed over the last 40 years. So here is a device that holds 6 option ROMs, let you switch in between it. Here is the dial-a-ROM that lets you do the same thing, holds up to 16 ROMs. So it's amazing. This guy has replaced this whole thing. But this is cool because it takes the actual ROMs, and it was a solution from back in the day. And it came with this pretty nifty battery pack, which is all working now. I originally intended this to all be in one video, but that Chipmunk disk drive was just a little cantankerous. We got the Model 100 callback fixed pretty quick. The ROM bank wasn't too difficult. Build a new battery bank, replace some caps and fix some traces, and that worked out real well. So I thought, well, we're getting close to half an hour here. We'll, stop the first part here, and then we'll have another part with just that Chipmunk drive because they are a little bit difficult to work on, and maybe that'll make it easier for somebody to find. Just a video on the Chipmunk drive since there's not too much out there about it. At any rate, thanks for watching. If you have any questions or comments, leave them in the comment section down there below. Would love to hear from you. Thanks to everyone who helps support the Hey Birt channel. It is greatly appreciated. And until next time, bye.